A spacecraft P of mass m moves in a straight line towards O. So P, which is here, is moving towards O. Great. The radius of the Earth is r. So here to here is r, where P is the distance x from O, including the radius. So it's from the center of the sphere. Okay. The force exerted by the Earth on P, towards O, has a magnitude of kx squared. So, given the air resistance can be ignored. I think it's been accelerated, is it? It doesn't say it's being repelled. And the force exerted the Earth is directed towards O. There it is, directed towards O. So it's being accelerated towards it. It's not being repelled. Is that okay? Show that K equals mr squared, right? So let's start off with, it's a force, isn't it? So what's force? Ma. Force equals ma. And ma equals,
but in this case, since it's going to the Earth, it's g.
because it's gravity.
Yeah.
I think that's what they're going for, is it? Yeah. That they're the same.
It says g in the answer, so.
Yeah. No, just want to know where to pull that out of, though.
It's because the acceleration equals g when it's at r. So when x equals r, a equals g.
Oh yeah. When you're on the surface of the planet, the acceleration is g at that point. Alright? It's sort of weird they didn't specify that they're talking about the force of gravity, though. It's weird. Anywho. Right. So if you replace the x value, the x value with r, you're at the surface of the planet, and when you're at the surface of the planet, that has to be the same as gravity, right? So it is ma equals k over x squared. Actually, I think it should be, just k over x squared, right? Now we're going to replace a with g, because g is gravity, and if you use gravity, it has to be capital R squared, and then, as you said earlier, just cross multiply up and you get k equals mgr squared. Just as well as a proof question, otherwise you might not really know what to do with it. The fact that to show that question gives you that little helping hand as to what to do. Alright. P starts from rest when it's a distance of O, when its distance from O is 5r. Find in terms of r the speed it hits the surface of the Earth at. Now, that means that, so speed it hits the surface of the Earth at. Okay, we're going to go force, as we already know earlier, is, they used minus, do you see that? Just one sec. 5r and r. And then the minus disappears. No, it doesn't disappear. Why did they use negative? Think. Huh? Yeah, we'll find out. I'm inclined just to go with the positive one. So it says it's not negative for the first one. Yeah. So the first part of the market scheme, it's not negative. It's not negative mgr squared, is it? Okay. So all of a sudden they want to take out negative out of nowhere. Let's find out why. Alright. So you're here and you're a distance 5r away. We've established that. You're going to stop here. Why are you stopping here? R. And 5r. You start off a distance 5r away. You stop a distance r away. You know that velocity can never be negative. Okay? And you can't square root a negative number. Alright? So what we'll do is I'll run through the system as if it's positive. If you identify an error at the end where phi squared is equal to a negative number, then you know maybe I should have thought about that being negative instead. Okay? That'd be the only, I would have went through it as positive, to be honest. Now, alright, let's just roll with this for a minute and see what happens. I'm just seeing what happens if I disagree with the marking scheme. You can't just follow it blindly after all, okay? Now, what's a k over x squared? We good so far? Then MA, lads, is what? MA? For force. What can I change k into?
G1 squared.
Over? X squared, okay. You're going from 5r to r. I'm still thinking about that. Alright. It'll come clear to me in a minute. I'll just drive through and get my attempt marks anyway. That's what you do in the test, to be honest. Now, choices. What are we looking at here? We're looking at, we want speed and using distance. So we're going to use phi times. Yeah, has to be the correct choice. So phi times dv dx, and that equals g r squared over x squared. Okay, let's cross multiply that. So phi dv ends up to be g r squared x squared, x minus 2, thank you Mick. And then we're going to integrate this, and when we integrate this we're going to get it from, starts from rest, that's paired off with 5r. There it is, finally, got it. Right, I know why it's negative. Alright, took that long for me to figure it out. X is going in the opposite direction. Sorry, X is going, I think X is going in the opposite direction to the, so the distance is measured outwards, isn't it? Would you agree with that? X is measured going technically left to right. Would you agree with that? So X is measured going left to right. I'll put a horizontal to make this a bit easier. So in a case like this where you can't think of whether it's positive or negative and you don't want to waste the next 5 or 10 minutes thinking about it, just go through all your workings anyway, put all your marks on the board, then make a call at the end of the question, positive or negative. Do not want to be sitting there doing nothing for 5-6 minutes. Can't afford that time. Okay. Now, here's what we're getting at, and I'm going to explain this to you now. Right. So this is P. We cool with that? What way is the distance measured from? It's measured left to right, isn't it? That's a distance of r. That's a distance of 5r. What direction is the acceleration going in? Going in the opposite direction. My prediction is that we're going to get a phi squared equals a negative number, and that will highlight what we just said there. Okay, let's find out. Okay, so what happens here? Yes, Connor?
If you use if you use like 4 instead, would that be fine with the positive value of the force?
We'll try it out in a minute. I'll find that hard to do in my head, to be honest. Right, so r there, yeah? And here's what we're going to do. We're going to go for phi squared over 2 from v to 0. And we're going to go for, that's the variable there, isn't it? So add on 1 and you get minus g r squared x and g r squared x, but it's actually x to the minus 1, isn't it? So the x will be on the bottom. Divide by the new power, so it's over 1x, yeah? And what happens to the two minuses? Huh? Yeah, they become positive, so that's alright. It's looking like it's staying positive, but I think the limits are going to fix that for me right now in a second. Okay. Now what do we get next? Yeah. So it's GR squared divided by 5R. Yes, Connor?
Would the derivative be negative?
It's going to be negative in a second, yeah.
But wouldn't it be negative like when you get the...
Oh, sorry, I did that a second ago. It was already, what was it?
It should be,
Oh, it wasn't negative already.
No.
no,
Sorry, my bad. So, thanks, Connor. So, it was x to the minus 1 over minus 1 multiplied the original positive number. Thank you. So, it's minus GR squared over x. So, quick fix there. That turns into a minus and that one turns into a plus. And this is...
you need to switch the R's. Because you got 5 R on the bottom of the first one.
Oh, it's R and 5R. Thank you. Awesome. Right. And that's what we were expecting, wasn't it? We were partially expecting we're sort of expecting it to be negative. So it's minus 1 plus a fifth, which is minus 4 fifths. And this is going to be phi squared over 2. We can't square root a negative number. So what does that back up? Even if you didn't understand the question, what theory would that back up? That at the very beginning, all the way up here, I didn't account for the fact that x and the force are measured in different directions, which means at the very beginning, should have had a minus here, and you see it's such a quick fix. Plus, minus, and you've spent all that time doing your stuff anyway, and there you go. And there's your answer, HER over 5. Anybody get it? Yeah. Did you have any idea why it was negative at the time?
No.
Alright. So,